Assalamualaikum warahmatullahi wabarakatuh. Welcome to the manufacturing process tutorial for the manufacturing system laboratory. In this video, we will learn the first module, which is introduction module. Okay, let's start with the first one. So, what is manufacturing process? So, manufacturing process is a series of activities that convert raw materials into finished product that have a higher selling value. This process involves various stages, starting from product design, procurement of raw materials, assembly, to testing and packaging. Okay, next. What is computer-aided design? So, computer-aided design is a digitalization method in designing and analyzing a product with the help of a computer. This technology is used by various design scopes such as electronic product and others. Some software in CAD or CAD are AutoCAD, Fusion, SolidWorks, and others. Okay, next about computer-aided manufacturing. So what is computer-aided manufacturing? Computer-aided manufacturing is an application technology that uses computer softwares and machines to facilitate and automate manufacturing process. So computer-aided manufacturing is the successor to computer-aided engineering and is often used in conjunction with computer-aided design. Okay, next is about bill of material. So what is bill of material? Bill of material is a complete list of raw materials, components, sub-assemblies, and other parts required to manufacture a product. Bill of material is one way to find out information about the manufacture of a product. Bill of material is a list of information about the number of components, part number, part name, material, quantity, make or buy. So there is bill of material. So next, from a table, we move on to the multi-level tree bill of material. Here is represented in a tree form. The lowest components are placed at level 2, then assembled into a sub-assembly at level 1, with the main product at level 0. Each number on the tree corresponds to information explained in the next slide. For example, part of explanation involves a component named iron sight, marked 321. The 3 is for process sequence, number 2 is for level, number 1 for material code, which is iron here, and then 3 here for part quantity. For example, if the material code is 1, it represents iron. If it's 2, it represents wood. Therefore, in this case, 1 signifies that the material is iron. The quantity of iron sight is 3. Okay, next we move on to the assembly chart. So what is assembly chart? Assembly chart defined as a diagram that depicts the sequence of steps in assembling product. Assembly chart serves to show the sequence of flow of components and sub-assemblies that will be assembled into a finished product. Okay, next, for example, part number are listed inside the circle here, corresponding to the parts in the previous bill of material. The part names are placed above the lines. Okay, let's move on to the right side. Okay, here, the A1 move next to the left side. The chart narrows down into sub-assembly and sub-assemblies, which shows how smaller components combine into the final product. The more leftward, the more sub-assemblies are created, and instead of writing SSS or sub multiple times. For example, if inside the circle is soup, there are 5 soup, so you can write inside the circle only S5A. Okay, after inside the circle is A1 or assembly 1, in the below you can see there is I1 or inspection 1. Okay, next, for example, if the top side already exists SSA2 number 2, so here you can put only SSA3, so 2 into 3. So the next for SSA2, after this you can put only SS3. Okay, next example, if the top side already exists SA3, so you can put SA4. Okay, next about operation process chart. So operation process chart or OPC is a diagram that describes the steps in a process sequentially from raw materials to finished product. This diagram uses standard symbols to indicate the types of operations, inspections, transportation, storage, and delays that occur in the process. Okay, next about the symbols in operation process chart. So first, here's circle. Circle is for operation. So operating activities occur when the workpiece undergoes change in properties. Okay, next is square. So here's for examination. So here's like inspection here. And then the third symbols is triangle. This is for storage. So let's we move to this part. So inside the circle there are part number here from a bill of material. So for the right side you can see there is operation name and machine name and tools. In the left side you can put time process and supporting components. Okay, next for size and tolerance. Tolerance is a deviation that is allowed or permitted. Each basic size is given two permissible deviation, namely upper deviation and lower deviation, because with the deviation, a workpiece is made and processed using tolerance so that the workpiece can be installed and assembled. Next, about general tolerance is a measure given for a process that doesn't require precision or is not part of a paired object. The general tolerance value always has the same upper and lower deviation limits. So the quality level or surface hardness and basic size are determined by the amount tolerance. Okay, this is for size and tolerance. There are fine deviation, medium deviation, and gross deviation. So that means having the right size accuracy of both parts when assembled. Okay, the second one is for having the right size accuracy of both parts when assembled. And then the last here is for if the measurement not having the right size accuracy of both parts when assembled. For example, here, if the size of the material more than 0.5 until 3, so the precise tolerance is more than less 0.05. Okay, next about process plan sheet. So here is a representation in the form of a sheet that states the sequence or order of operations along with their parameters in making parts of a product. Some points that must be considered in filling out the process plan sheet table are, so first, there are process number, next about operation description, workstation, setup number, setup tools, setup time, process time, and the last is for total time. So here's the example for process plan sheet. Okay, next about engineering drawings are visual communication tools used to convey information about the design of a product in a communicative, normative, accurate, measurable, and effective manner. Next about engineering drawing. So this is projection is divided into two. So the first one is American projection and then the second one is European projection. So for the example, the first one is American projection. So as you can see, here's the isometric view here, and then the top view here, the front view here, and then the right view in here. So this is the example for European projection. Okay, the last one is for Gantt chart. It's a planning diagram used for resource scheduling and time allocation. Gantt chart can help its users to ensure that all activities have been planned, the sequence of performance has been calculated, the estimate time of activities has been recorded, and the overall project time has been created. Okay, next, for example, one box here means 1 second, so the iron elbow here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 seconds in hand grinding. Okay, next example. This part, namely big pipe, 1, 2, 3, so big pipe have 3 seconds in freeze machine. Okay, thank you for watching this tutorial on the introduction module for the manufacturing process. Wassalamualaikum warahmatullahi wabarakatuh.